Section 1.2.5 Databases in the Cloud, SQL versus NoSQL and Managed Services. When we talk about databases in the cloud, we're really diving into the part of the system that remembers. And I want you to actually stop on that idea for a moment. Remembers. Not like temporary memory in RAM that vanishes when things restart. No, this is memory in the human sense. Facts, history, promises already made. Think about the last time you bought something online. You clicked buy, money left your account, and an order appeared in your profile. Now pause here. That information can't be almost correct. It can't disappear for 2 seconds. And it absolutely can't change its mind later. If it does, the problem isn't small, trust breaks, systems fail. That's what a database protects. It's not just a storage spot, it's the keeper of truth. It remembers who you are, what you've done, and what the system has promised. And here's something people often underestimate. If that truth goes wrong, the entire application starts lying to users, to other systems, and eventually to itself. That's why database decisions might seem boring at first, but become painful when wrong. Get it wrong, and strange things happen. An order vanishes, a shopping cart empties itself, or a page refresh shows something different every time. Get it right, and the system feels calm, predictable, stable, almost boring. And in infrastructure, boring is exactly what you want. Now let's bring in the cloud. In the cloud era, especially as we move through 2025, choosing a database almost never means installing software on your own server anymore. That world still exists for specialized cases, but it's no longer where most teams live. Today, databases are usually managed services, and this shift matters more than it sounds. It means the cloud provider handles the grunt work that used to keep engineers awake at night. Backups, failovers, patching, scaling, and basic security. You're no longer fixing the database at 3 a.m. Your focus shifts upward to deciding something fundamental. What kind of truth does this system need to protect? Before we dive into managed services, we need to unpack the core decision underneath almost every database choice. SQL versus NoSQL. This isn't just tech jargon. It's a mental model that shapes how your system handles reality. Let's make it concrete with analogies. Because in audio, pictures in your mind stick better. A helpful way to understand SQL is to imagine a very strict library. Every book has a defined place on the shelf. Every shelf follows clear rules, and books reference each other in ways that must always make sense. If a book is missing or misplaced, the librarian stops everything immediately. No guessing, no improvisation, no, we'll fix it later. That's SQL. Data lives in tables with fixed schemas. Rows and columns follow strict rules, and relationships are enforced through keys. This structure lets you ask powerful, complex questions like, show me all customers who bought widgets last month, their total spend, and linked inventory levels. SQL shines when relationships matter and mistakes aren't acceptable. Think money transfers, inventory counts, ownership records, or orders. If a bank said, your balance might be wrong, but it'll fix itself later, that bank wouldn't last long. SQL enforces ACID properties, atomicity, consistency, isolation, durability, ensuring transactions are all or nothing and data stays reliable. Now imagine something very different. Instead of a library, picture a large, adaptable warehouse. Boxes everywhere. Some hold documents, some lists, some data that looks completely different from the rest. You can add new kinds of boxes anytime without reorganizing the entire space. That's NoSQL, which stands for not only SQL. It trades rigid structure for flexibility and speed, using models like documents, JSON-like, key-value pairs, wide columns, or graphs. This makes it perfect when data changes shape often, volume is massive, or speed trumps perfect agreement. Think activity logs, click streams, sensor data from IoT devices, or social interactions. Here's a moment almost everyone recognizes. You like a post, refresh the page, and the like is gone. Then refresh again, and it's back. Nothing's broken. The system just chose speed over instant agreement. That's eventual consistency. Part of the base model, basically available, soft state, eventual consistency, where NoSQL prioritizes availability and scalability. Here's the insight that unlocks most confusion. SQL isn't old and slow. NoSQL isn't new and magical. Neither is inherently better. They solve different problems. And this often surprises people. Research from 2025 shows SQL is actually making a strong comeback, dominating developer surveys and adoption rates due to cloud enhancements like better horizontal scaling and AI integrations. For example, vector search for recommendation systems. NoSQL still excels in high-velocity niches, but smart teams use polyglot persistence, blending both. Real systems don't choose sides. They combine CQL for relational truth, who owns what, NoSQL for performance truth, handle a million users now. Now let's slow down again. This connects to something called the CAP theorem. But we don't need heavy theory here. In distributed systems like cloud databases, spanning regions, you make trade-offs. You can prioritize consistency. Everyone sees the same data, availability, system always responds, or partition tolerance, handles network failures. But you can't max all three at once. SQL often leans toward consistency. If something's wrong, it'd rather pause than lie. NoSQL prioritizes availability, responding fast and syncing later. Neither is wrong, they just answer different workload questions. In cloud environments, this means SQL for mission-critical ops, where downtime is okay but errors aren't, and NoSQL for global apps, where speed and resilience matter most. This is where myths cause real trouble, based on common developer discussions. One big myth: NoSQL means no SQL at all. Nope, it's not only SQL, and many NoSQL databases like MongoDB now support SQL-like queries. Another: SQL can't scale. Modern cloud SQL scales horizontally, via read replicas and sharding. Issues usually stem from poor design, not the tech. On the flip side, NoSQL isn't always faster. If you need complex relationships, you denormalize, duplicate data, and duplicates can drift, causing inconsistencies. A frequent pitfall: adopting NoSQL too early for relational needs, leading to schema chaos and query inefficiencies. Or thinking managed services make everything effortless. They reduce ops, but you still tune for costs and consistency. To illustrate these trade-offs, consider aspects like data structure, where SQL uses tables with fixed schemas, rows and columns, while NoSQL is flexible with documents, key value, graphs. For consistency, SQL offers strong ACID, immediate accuracy, NoSQL eventual base, speed over perfection. Scaling in SQL is vertical or horizontal with read replicas. In NoSQL, horizontal sharding. Easy distribution. Use cases for SQL include transactions, finance, e-commerce orders. For NoSQL, logs, real-time data, social feeds. Strengths of SQL are complex queries, relationships. Weaknesses: rigid for changing data. For NoSQL, strengths: high throughput, schema evolution. Weaknesses: weaker for joins, potential inconsistencies. In 2025 trends, SQL has AI vector support, resurgence in adoption, NoSQL price optimizations, global replication. Now let's return to managed databases with this context. Running your own is like being chef, waiter, and plumber in a restaurant. Exhausting. Managed services flip it. The provider runs the kitchen, you design the menu. Take AWS RDS, a fully managed SQL service supporting engines like PostgreSQL or MySQL. It automates backups, point-in-time recovery, scaling, add read replicas for queries and high availability, multi-AZ failovers for 99.99% uptime. Using AWS Graviton 3 processors in 2025, it boosts price performance. Amazon Aurora supercharges this by separating compute from storage. You scale processing independently, achieving 5 times MySQL throughput and 3 times PostgreSQL, with distributed storage across zones for fault tolerance. It's PostgreSQL MySQL compatible, now with enhanced vector search for AI. On the NoSQL side, AWS DynamoDB is serverless magic. No servers to manage, just pay for requests. It handles millions per second with single-digit millisecond latency, using global tables for multi-region replication and tunable consistency, strong or eventual. In 2025, it features up to 67% price reductions on global tables and 50% on on-demand capacity, making it ideal for apps like Disney Plus or Zoom handling surges. Other providers mirror this. Azure Cosmos DB offers multi-model support, SQL NoSQL hybrids with 5 consistency levels, and AI-ready vector search. Google Firestore provides real-time sync for collaborative tools. Now MongoDB compatible with 99.999% SLA. Google Alloy DB adds columnar engines for 100 times faster PostgreSQL analytics. Here's the beginner mistake to avoid. Don't memorize names. Grasp patterns. Manage databases, accelerate execution, but don't replace thinking. Watch costs, for example, data egress fees. Understand consistency and design for workloads. Cloud economic supply. OPEX. Pay-as-you-go beats CapEx. Upfront hardware, with elasticity for spikes like Black Friday. Most modern systems are hybrids. This is maturity, not confusion. Banks like Capital One use SQL RDS for ACID-secure transactions. E-commerce like Amazon blends DynamoDB for carts. Fast, scalable with Aurora for orders. Consistent. Netflix, SQL for profiles. Relationships, NoSQL for logs. Volume, feeding BigQuery analytics. Spotify, SQL for playlists, NoSQL for behaviors. Per 2025 Gartner reports, 80% plus of enterprises use both, with trends toward multi-model databases. For example, Cosmos DB and AI integrations, vector DBs for embeddings. In interviews, this mindset stands out, not defending tech, but explaining trade-offs. If asked, SQL or NoSQL for e-commerce, you'd say hybrid, SQL for orders, ACID via Aurora, NoSQL for recommendations, vector in Cosmos DB, scale reads with replicas, or KP implications. In cloud, SQL prioritizes consistency for finance, NoSQL availability for global apps. When does NoSQL hurt? Complex joins or strong consistency, then SQL shines. That's confidence, architectural, not ideological. Databases aren't one-time picks. They're commitments to your system's reality. SQL guards structured truth with rigor. NoSQL unleashes flexible truth with agility. Managed services safeguard your time and sanity. And once truth is stored safely, the next question arises. How do we make it fast? That's where caching comes in, turning slow truths into lightning responses. Expanded exploration of cloud databases, concepts, trends, and practical insights. When we delve into databases in the cloud, we're essentially exploring the foundational element that acts as the system's long-term memory, preserving not just data, but the very truths that underpin application reliability and user trust. This memory isn't fleeting like RAM, which evaporates upon restart. It's enduring, capturing facts, historical records, and commitments made by the system. For instance, recall an online purchase. Clicking Buy deducts funds and logs an order. That record must remain impeccably accurate. No temporary lapses or retroactive changes. Lest trust erodes and the system falters. Databases safeguard this integrity, preventing scenarios where applications propagate falsehoods to users or interconnected components, ultimately undermining their own operations. Decisions around databases may appear mundane initially, yet errors here manifest dramatically. Vanished orders, self-clearing carts, or inconsistent page loads. Conversely, sound choices yield stability, a boring predictability that's the hallmark of robust infrastructure. In today's cloud landscape, particularly as of late 2025, selecting a database seldom involves self-hosted installations on physical servers. While such setups persist for niche requirements, the norm has shifted to managed services, a transformation that profoundly impacts development workflows. Providers now shoulder the burdensome tasks: automatic backups, seamless failovers during outages, security patching, dynamic scaling to handle load fluctuations, and foundational security measures that once demanded round-the-clock vigilance from engineers. This liberation from 3 a.m. troubleshooting allows focus on strategic concerns. What specific truths must the system uphold? Central to this is the dichotomy between SQL and NoSQL, not mere terminology, but a paradigm-defining data handling. Analogies clarify this. Envision SQL as a meticulously organized library where each book occupies a precise slot. Shelves adhere to rigid protocols, and cross-references maintain unerring logic. Any discrepancy halts proceedings, no ad hoc fixes. Thus, SQL structures data in tables with predefined schemas, enforcing row-column discipline and key-based relationships. This enables intricate queries, such as aggregating customer purchases with expenditure and inventory links. SQL thrives in domains where precision is paramount. Financial transactions, stock management, asset ownership, order processing, bolstered by ACID guarantees, atomicity for indivisible operations, consistency for valid states, isolation for concurrent integrity, durability for persistence post-commit. Contrastingly, NoSQL evokes a vast, versatile warehouse, boxes of varied contents, documents, lists, disparate formats, added freely without wholesale reorganization. Prioritizing agility over rigidity, it employs models like JSON documents, key value stores, column families, or graphs, suiting evolving schemas, immense volumes, or scenarios favoring velocity over absolute synchronicity, e.g., event logs, user interactions, IoT streams, social engagements. A familiar glitch, liking a post only for it to vanish on refresh before reappearing, illustrates eventual consistency within base. Basically available for uptime, soft state for flexibility, eventual consistency for deferred alignment, emphasizing scalability. The crux, neither paradigm is superior, they address distinct challenges. Counterintuitively, 2025 data reveals SQL's resurgence, topping adoption charts via cloud-driven advancements in horizontal scaling and AI, including vector search for semantic queries and recommendations. NoSQL dominates rapid, unstructured flows, yet astute practitioners embrace polyglot strategies, merging both for relational fidelity, SQL, and performative efficiency, NoSQL. This interplay resonates with the CAP theorem's essence. In distributed setups like multi-regional cloud databases, one trades off consistency, uniform views, availability, constant responsiveness, or partition tolerance, failure resilience, impossible to maximize all. SQL favors consistency, opting for halts over inaccuracies. NoSQL leans availability, syncing post-haste. These choices suit varied contexts. SQL for error-intolerant critical functions, NoSQL for resilient global operations. Myths abound, per developer forums. NoSQL isn't SQL's antithesis, but a complement, with tools like MongoDB incorporating SQL-esque querying. SQL scales adeptly in clouds through replicas and partitioning. Design flaws, not inherent limits, cause bottlenecks. NoSQL's speed falters in relational demands, necessitating denormalization and risking data drift. Pitfalls include premature NoSQL adoption for structured needs, yielding disorganized schemas, or presuming managed services eliminate all oversight. They streamline but demand cost and consistency vigilance. Trade-offs manifest across dimensions. SQL's tabular schemas contrast NoSQL's adaptable formats. ACID's immediacy versus base's velocity. SQL's replica-based scaling against NoSQL's sharding. Transactional use cases like finance for SQL, real-time feeds for NoSQL. SQL's query prowess offset by rigidity, NoSQL's throughput by join weaknesses. 2025 trends amplify this. SQL integrates AI vectors for resurgence, NoSQL optimizes pricing and replication. Turning to managed databases, self-management mirrors solo restaurant operations, cooking, serving, plumbing, taxing. Managed alternatives delegate, freeing innovation. AWS RDS exemplifies, fully handling SQL engines, PostgreSQL, MySQL, with auto backups, point in time, query replicas, multi-AZ uptime, 99.99%. Enhanced by 2025 Graviton 3 efficiency. Aurora elevates, decoupling compute/storage for independent scaling, yielding 5 times MySQL/3 times PostgreSQL speeds, zonal distribution, PostgreSQL/MySQL compatibility, plus AI vectors. NoSQL's DynamoDB epitomizes serverlessness. No infrastructure oversight. Request-based billing. It manages millions per second at millisecond latencies, global tables for replication, adjustable consistency. 2025 brings 67% global table/50% on-demand reductions, suiting surge-heavy apps like Disney Plus or Zoom. Parallels include Azure Cosmos DB's multi-model SQL/NoSQL with 5 consistencies and AI vectors. Google Firestore's real-time sync, MongoDB compatibility, GA 2025, 99.999% SLA, AlloyDB's columnar acceleration for 100 times PostgreSQL analytics. Novice error, prioritizing names over patterns. Managed accelerates but necessitates oversight. Egress fees, consistency tweaks, workload alignment. Economics favor OPEX's flexibility over CapEx's upfronts, with elasticity for peaks. Hybrids define modernity, not disarray but sophistication. Capital One leverages RDS for ACID trades. Amazon fuses DynamoDB carts, scalable, with Aurora orders, consistent. Netflix pairs SQL profiles, relational, and NoSQL logs, voluminous. Piping to BigQuery. Spotify mirrors with SQL playlists and NoSQL behaviors. Gartner 2025 notes 80% plus enterprise hybrids, trending multi-models, Cosmos DB, and AI vectors for embeddings. Interviews reward this nuance. Not advocacy, but trade-off articulation. On e-commerce, hybrid, SQL orders, Aurora ACID, NoSQL recommendations, Cosmos vectors, replica-scaled reads. CAP, Cloud SQL consistency in finance, NoSQL availability globally. NoSQL drawbacks. Joins just strong consistency, SQL prevails. This breeds architectural assurance. Databases commit to systemic reality. SQL's rigorous structure, NoSQL's agile flexibility, manages operational safeguard. With truth secured, speed beckons. Caching transforms sluggish access into swift insights. Once databases are chosen to protect truth and consistency, the next architectural question is no longer where data lives, but how often we need to ask for it. And that question leads us directly into the next chapter. Caching. End of section 1.2.5.